Welcome to the Sutron MeteoStar Weather Solutions Division. MeteoStar. MeteoStar was founded by Lockheed Martin in 1992 to support a U.S. Navy weather program, and through a series of acquisitions is now part of the AMS Hydromet Group. MeteoStar is located in the mountains of Colorado, close to Denver, and we welcome any who would like to visit. Our product solutions address many different weather applications. We thank you for the opportunity to discuss these with you today. MeteoStar, being a part of Sutron and the AMS Hydromet Group, can bring a full end-to-end solution to our customers' needs. End-to-end means, as a company, we can provide the measurement sensors, local data collection, and communications to a central station, forecasting tools, visualization, and alerting to the end user. Sense It means that environmental information is measured by AMS Hydromet sensors and data loggers. By Send It, we mean that data communications are available in real time to interface with the LEED central database. See It means that data is ingested by the MeteoStar LEED system and the capabilities of LEEDs are exploited by the user. For instance, LEEDs modules can create forecast products and provide a GIS mapping weather situation awareness. LEEDs can then distribute this information either locally or via the web to computers and smart devices. Supporting the decision process means that users can assign limits to the data and then create watches, warnings, and alerts. Bulletins are also based on the data values and pushed to users. Data presentation styles can be easily created by the user to support a variety of decision processes. MeteoStar LEEDs is all about using data to make decisions. Decisions to prevent the loss of life and support an economic enterprise. For meteorology, LEEDs support better forecasts, saving lives, assets, and resources. For aviation, LEEDs provides aviation weather to support all phases of flight, including optimal flight planning, flight management following, and flight safety. MeteoStar LEEDs even provides weather in the cockpit for a number of airlines. Overall, LEEDs aviation weather saves fuel for the airlines and provides a comfortable flight for the passenger. LEEDs can include our environmental monitoring system, a totally EPA-compliant software suite to collect air quality data, provide QA and QC, and then publish EPA AirNow reports. LEEDs Hydro couples the atmospheric forecasting of rainfall with the surface hydro models. Using the latest in NCAR WRF Hydro and National Weather Service CHPS FEWS, LEEDs Hydro can provide a contemporary hydrology system. Add the AMS Hydromet sensors and data collection, and Sutron MeteoStar can provide a complete end-to-end hydrology solution. The marine sea state is driven by the winds and tides. MeteoStar can offer a complete oceanographic system from the satellite measurement of sea surface temperature to the winds forecasts that drive the wave models. When severe weather strikes, emergency management goes to work. Timely LEEDs forecasting provides early warnings, bulletins, and a better support for the decision process. LEEDs forecasts and situation awareness provide for the strategic management of assets and resources to minimize the effects of severe weather events, saving people and property. MeteoStar is a global provider of weather information systems used in a variety of different markets for different applications. In the U.S., LEEDs supports the Army, Navy, and Air Force. International military support ranges from Asia to Europe. Commercial aviation uses LEEDs weather products and systems to manage weather-impacted operations. International civil aviation authorities use LEEDs to provide weather information to manage their airspace. Rocket launch facilities use LEEDs to create the launch commit criteria required by their range operations. Aviation weather service providers that support commercial and general aviation rely on LEEDs to provide a complete set of aviation weather products. Energy generation and power utilities use LEEDs forecasts and information to manage their operations. Others, ranging from national Met services to canal operations, rely on LEEDs for forecasting and supporting their decision process. The MeteoStar focuses on the customer and their requirements. Our emphasis is understanding the user requirements and providing a complete leads-based solution. The graphic depicts the decision maker as central to the process of bringing value to the customer through forecasting and providing weather situation awareness as the basis of decision support. These decision support and alerting capabilities are designed to support several markets. Weather forecasting through applied meteorology to severe weather forecasting and fire weather applications and support. Aviation operations through air traffic control, flight planning, and flight route management. Hydrology through flood and flash flood guidance and forecasting and water use management. The LEAD solution is modular and scalable. LEADs can support small systems to large systems requirements. To add additional sensors just requires the addition of another ingest decoder. To add additional processing capabilities, just upgrade or add additional servers. This figure illustrates the typical LEADs architecture. Sensor data is ingested and placed into an operational database. From there, LEADs can process the data to create forecasts and displays of weather situation awareness from a set of LEADs HydroMet applications. Data is visualized on a local workstation or passed to our LEADs Online or IGM web front end for viewing. Watch and alert bulletins can be created and passed to users via a number of methods, such as SMS, email, audio, etc. MeteoStar can also provide apps for smart devices, putting weather in the hand of the user. The key features of LEADs are shown on the left of the screen and include not only the LEADs capabilities, but those of MeteoStar to provide a comprehensive solution. LEADs builds products in layers. The example shown here consists of static map and topo layers, and LEADs products consisting of surface plots. The MeteoStar
SLP
tool
contours,
used for building weather
satellite
products
images,
is the LEADs weather
and user-drawn
workstation.
symbols.
The weather workstation can build any product the user can assemble from data in the LEADs database.
These layers can be added to a composite
As these products are
product for
built,
display
the user can
or
record the
delivered through our
process
web
as a script
interfaces.
or a macro. Once the
LEADs
script is
products can be
recorded,
tailored to
products
support
can be
different
automatically
applications or
generated with the
industries.
LEADs Automatic
Some
Product
examples
Generator,
include
or APG for short.
aviation weather support,
The APG can build products
meteorological
on a
operations,
user-defined schedule,
media
or
and
when
public
new data
awareness,
arrives into the database.
hydrological
Once the products are
applications,
built, they are placed in an operational
agricultural and
database
maritime
where they can be
forecasting.
used or modified by other
LEADs
weather
web displays can
workstations or
support
viewed by
viewing
the LEADs
individual
web
layers
tools.
as shown
The
here
products shown
over a
above
GIS
are
map, or
enhanced
as complete
satellite
products
IR
using
imagery
LEADs
over
Online.
Southeast Asia, weather radar depiction from a WRF model run, time series of a local airport weather station. LEADs can ingest and create products from many types of environmental data. The next slides provide several examples of the LEADs capabilities for weather radar, satellite, numerical weather products, and oceanographic products. The examples shown here are weather radar. LEADs can display and loop a single radar site or mosaic several sites into a regional or national radar composite. LEADs can also layer other products with the radar such as satellite imagery, lightning, and surface stations, all of which add value to forecast accuracy. Leads can also derive information from a radar image or a volume scan, such as precipitation type, accumulated precipitation, wind fields, and echotops. The radar images shown in this slide are examples of the UK Radar Network, Australian Radar Network, Thailand WRF radar depiction, and the Japanese National Radar Network. This slide shows an example of leads management and display of satellite data. The examples show multiple satellites combined with lightning, surface, METWatch, and contour product layers all being looped. Product examples include, from top to bottom, a blended satellite image using the Japanese Himawari satellite, Meteosat 7, and the Chinese FY series over Asia and the Eastern Pacific. The leads processing is enhanced infrared with looping. Visible Himawari data with the surface METWatch and isobar contour layers. These three layers are all being displayed and looped. Himawari IR and lightning layers, which can also be looped. Leads provides the forecaster or user with all the tools to use and manage numerical weather prediction or model data. Leads can ingest model data in a variety of different formats. Examples include the ECMWF model precipitation type over Europe, WRF turbulence LROD derived products over Southeast Asia, WRF total precipitation and cloud cover over central Thailand and the surrounding areas, and the WRF total precipitation and cloud cover product over India and Tibet. Leads can display a variety of oceanographic products. Shown in this slide are satellite sea surface temperature, joint typhoon center typhoon track with satellite IR imagery, composite weather radar showing a hurricane over the eastern coast of the United States. Also showing are the airport METARs from Leads METWatch, wave heights from the WaveWatch 3 model. Leads Aviation is a net-centric solution that can be utilized by aviation users to meet their weather forecasting objectives. The Leads system can manage all relevant data into one integrated database. The database can be interrogated, forecasts generated, the current weather monitored, products visualized, and alarms and alerts set on data and conditions. Using the Leads system, users can disseminate valuable weather information to all users in the enterprise. These include dispatch, flight planning, ramp operations, and customers. In addition, Leads web-based and interactive GIS mapping can also provide the collaboration tools to work across the user's enterprise. Since Leads was originally developed for the aviation market, the following describes the Leads aviation capabilities. Note that MeteoStar Leads services not only civil aviation authorities, but airline service companies like Sabre Flight Explorer and Lufthansa Lido Flight Winds, as well as individual airlines such as KLM, Air France, and others. Leads supports and brings value to all phases of flight, from flight planning, TAF generation, flight following, and air traffic management. The figures on this slide include a significant weather chart from the UK Bracknell Center and a depiction of turbulence as a Leads WRF-derived product over Southeast Asia. Knowing the current and forecast weather, or weather situation awareness, is key to managing an airport, airline, or individual flight plans. In 2004, 76% of aircraft delays were due to weather. We can't change the weather, but having up-to-date weather can help plan to mitigate costly delays due to weather. Leads can ingest all aviation weather information and place this in a four-dimensional weather aviation database. Four-dimensional means latitude, longitude, altitude, and time. Very simply, Leads allows a user to fly an aircraft through this operational weather cube and note any intersections with weather conditions that might interfere with the flight plan or air traffic control, such as turbulence, winds, icing, visibility, and etc., and then plan accordingly. Accurate terminal area forecasts, or TAFs, are critical to flight planning and airspace management. Leads provides a set of graphical tools to assist in the creation of TAFs. The user can select an available numerical weather model, and Leads will create a first guess TAF for any latitude or longitude. The user can modify the first guess TAF by graphically dragging the polygons representing the physical weather parameters such as temperature, winds, fog, turbulence, icing, and etc. to meet a better forecast. This process is called Forecaster in the Loop. As the weather parameters are graphically edited, the textual TAF is changed accordingly. Once the forecaster is confident with the TAF, they may then publish the TAF and export it to the AMHS system for dissemination. This chart is called the stoplight chart. The chart is a one-day forecast of airport weather on an hour-by-hour basis. The power of Leads is that the user can create almost any forecast product for a particular location by latitude and longitude, such as an airport, oil rig, or etc. This example creates forecasts for non-convective wind gusts, low-level wind shear, crosswinds, precipitation type, ceiling, visibility, thunderstorm threat potential, hail, convective gusts, 12-hour rain totals, 12-hour snow, and 6-hour rain accumulation. The user can set thresholds on the data parameters based on the flight requirements. These can be green, such as OK for VFR, yellow, such as caution for IFR, and red, indicating runway is closed. When yellow or red are seen in the forecast, the appropriate action can then be taken to change air traffic control patterns or to close runways. Note that this illustration is for airports, but the same concept can be used for emergency management criteria, such as flooding, typhoons, tornadoes, and other weather-related criteria. Forecasters pass weather-related information in the form of bulletins. Leads provides pre-configured bulletin templates for creating weather messages. Examples include general MET messages, such as METARs, TAFs, and SYNOPs, aviation bulletins, such as SIGMETs, AirMets, and volcanic ash bulletins. These bulletins are WMO and ICAO compliant for MET and aviation messages and can be easily passed to the GTS or ATN AFTN network switch. Weather situational awareness is vital to managing aviation and other operations. The user can immediately visualize the weather situation affecting an aircraft or a point in space. Leads generates weather products, and these are presented in layers over GIS maps. The mapping underlay can be Google Maps, Esri, OSM, flight charts, or custom user-generated maps. The graphics shown on this slide depict turbulence over the Pacific flight routes and a mosaic of weather radar and current METARs over the southern United States. Note that this weather situation awareness shows aviation-related applications. Situation weather awareness can also support emergency management and other applications like severe weather, flooding, and fire weather. Situation awareness can show when the event arrives, what the weather situation is now, and what it will be in the future. Leads can generate product cross-sections along a flight route. Products can be generated on demand or scheduled on the arrival of updated model runs. These examples depict cloud cover, turbulence, and icing. Leads has the capability to generate any number of specialized weather products. These weather products can be output in any number of formats and exported to third-party applications. The screen captures shown on this slide are the Sabre Flight Explorer display and the Lufthansa Lido Flight Winds display. The MeteoStar Leads Hydro hydrologic modeling and forecast system is a fully integrated hydrologic and hydraulic modeling platform and flood forecast system. An important feature of Leads Hydro is its applicability to any location globally due to the integration of the research distributed hydrological model parameter estimation capability. Leads Hydro consists of several major components, each with significant data requirements for full integration. These data requirements can be fulfilled in many ways, either by the client or MeteoStar, and, depending on the level of modeling precision needs of the user, the data can be relatively coarse, like the NASA SRTM elevation data, or very detailed, such as LiDAR digital terrain data. The critical point is that Leads Hydro can accommodate a full spectrum of data inputs. To get our terminology correct, hydrology and hydraulics involve water management once the rainfall is on the ground. Meteorology provides forecasts of rainfall before it falls to the ground. Leads can provide the coupled atmospheric to ground models for forecasting hydrology applications. The atmospheric model forecasts drive the input for the hydrologic models. Flash flood guidance uses satellite or weather radar to estimate heavy rainfall. Flash flood and flood forecasting use rainfall accumulation and hydrologic modeling for flow and stage. Leads incorporates the full CHPS, FEWS implementation and features. These features include QPE and QPF from NWP, radar and satellite, ensemble predictions, inundation mapping, and include applications supporting agriculture and water resource management. The pictures above illustrate the recent Thailand flooding in Bangkok. The upper right is a flood inundation depiction overlaid on a GIS map. The forecasting process is illustrated in the figure on the upper right. Each rainfall forecast time series, outlook, forecast, watch, and warning, is used to drive or input a hydrologic model and starts from 10 to 15 days before the event through the actual event. Rainfall outlooks are 10 to 15 days and are provided by the global models. These models provide guidance to carefully watch once rainfall is predicted. Rainfall forecasts are 3 days and are provided by mesoscale models. These models are more accurate than the global models and forecast rainfall. Rainfall watch is 1 hour and is provided by rainfall estimates from actual sensor measurements. These can be satellite, radar, or surface networks. Rainfall warning is 15 minutes and is provided by rainfall measurements from surface rainfall and stage instruments. This slide shows an example of a Leads Hydro modeling system in the Korea Imjin Basin. Note the surface network located in the basin. The Imjin Basin with its rivers is shown to the right. This slide shows examples of Leads hydraulic applications, including river routing, stage forecasting, and river inundation. The figures illustrate the HEC RAS calibration and model implementations. Leads Hydro uses ensembles to achieve the most accurate forecasts for risk-based decision-making. A good example showing results is shown in the next slide. This time-lapse depiction consists of a 4-kilometer distributed hydro model over a catchment in lower portions of Ohio showing discharge. The events are recorded from April through July in 1-hour increments. The hydro model input from weather radar and QPF inputs is shown on the right. Watch carefully as the precipitation events occur on the right and the corresponding discharge on the left. Note that the distributed model accounts for rainfall and discharge in 4-kilometer cells throughout the catchment. Compare this with a bulk model that considers an even rainfall over the entire catchment. The true power of leads is the ability to ingest disparate data types, place this data into a gridded database, and provide the user with a complete set of tools to create forecasts, visualize situation weather, create and publish bulletins, and automate watches and warnings. Then distribute these through a set of leads web-based tools and smart device apps. The graphics on this slide show a weather situation with layers containing warning and watch boxes, lightning and satellite imagery. Note that clicking on a watch box will bring up the associated bulletin. Model output showing a Leeds-derived Cape product over Southeast Asia, a MeteoStar smartphone app with weather radar imagery, and a meteogram depicting a time series of METAR data. In this slide, Leeds integrates the radar accumulated precip and surface rain gauge data on the same image. This type of information is useful in calibrating the Z to R relationship for weather radars. On the right is a weather radar display overlaid on a GIS map background. The associated lead script is to the right. Note the ease of changing radars and map backgrounds. Additional Leeds-derived products are shown on this slide. These products include model rainfall accumulation derived from the WRF and available for input to hydro models, weather radar reflectivity derived from a WRF model, Haynes Fire Weather Index derived from a WRF model that shows areas of fire danger, a composite imagery loop that contains satellite imagery, airport METARs color-coded to VFR and IFR, station plots, and isobars. The Leeds Climate Database System, or CDS, is a complement to the Leeds Weather Information System and provides climatological features for data query and analysis of archived data from most common sources, such as automatic weather stations, METARs, balloon soundings, lightning data feeds, and field mill sensors. The Leeds CDS software is a web-based system developed in Java that runs on top of Linux, PostgreSQL, and GeoServer. Leeds Climo meets the strong emphasis on historical climate data for analysis and trending. Leeds Climo is an application that brings a WMO-compliant solution to storing climate data along with the analysis and visualization power of Leeds. The graphic products in this slide illustrate the following: the computation of a convective available potential energy on a monthly basis for an entire year. Wind roses of direction and average speed. Yearly history of wind speed showing the daily max and mean. Note the graphic also shows the max and min of the datasets used to calculate the mean. Using Leads Climo and the power of Leads for computation, visualization, and report generation provides a valuable tool when looking at historic data. This slide shows time series charts of user-defined parameters. The example shown here illustrates the time series data of wind speed, wind direction, and precipitation. The user can choose any data in the database to display. The graph on the bottom figure shows a zoom in of the time series, which is another feature of Leads Climo. Some additional Leads Climo graphics are types of precipitation by percentage throughout the year, types of precipitation by month throughout the year, hourly daily temperature by day for a complete year, wind roses of wind speed and direction. This slide shows an analysis and display of lightning and electrical potential data. These examples include a histogram showing 12 years of historic lightning strike data by month, a time series of field mill, which is electric potential, and associated lightning strikes, which are indicated by circles corresponding to the polarity and magnitude of the strike. Events such as forest fire disasters cause large economic losses and displacement of people located within fire areas. These ongoing events have tragic and devastating consequences on the natural resources of the country, with impacts on the citizens, assets, infrastructure, and economy. The Leads Fire Weather application presents the integration of the Canadian fire weather indices within the MeteoStar Leads system. The Leads-based fire weather system will characterize and warn or alert of fire potential and also provide information relating to the containment and management of wildfires. The application will provide the forecasting and assessment of fire danger and provide collaboration tools with other responsible agencies, as well as the visualization, dissemination, and complete situational awareness to warn the public, support local firefighters, and emergency responders. Highlights of the Leads Fire Weather application are full implementation of the Canadian Fire Weather Model, computation of all the fire weather indices, ingest of weather model data for fire weather forecasting, and integrated use of MODIS satellite imagery to generate the fuels map database. The Leads Fire Weather System provides all fire weather indices using the basic inputs of relative humidity, daily temperature, precipitation, and wind speed. The Fire Weather Index system is a model that predicts the potential fire danger within the forest. The fire weather indices are Fine Fuel Moisture Code, FFMC. The FFMC is an indicator of the relative ease of ignition and flammability of fine fuel. Duff Moisture Code, DMC. The DMC gives an indication of fuel consumption in moderate duff layers and medium-sized woody material. Drought Code, DC. The drought code is a numerical rating of the average moisture content of deep, compact organic layers in the floor of the forest. The DC is a useful indicator of seasonal drought effects on the forest fuels and amount of smoldering in deep duff layers and large logs. Initial Spread Index. The Initial Spread Index is a numerical rating of the expected rate of fire spread. It combines the effects of wind and the fine fuel moisture code on rate of spread without the influence of different fuel types. Buildup Index, BI. The buildup index is a numerical rating of the total amount of fuel available for combustion that combines the Duff moisture code and the drought code. The Daily Severity Rating, DSR. The Daily Severity Rating is a numeric rating of the difficulty of controlling fires. It reflects more accurately the expected efforts required for fire suppression. Fire Weather Index, FWI. The Fire Weather Index is a numerical rating of fire intensity that combines the initial spread index and the buildup index. This slide contains examples of the fire weather indices for the Malaysia Peninsula and Brunei. These examples include Initial Spread Index, or the expected rate of fire spread; Fire Danger Intensity, or the relative ease of ignition and flammability of fine fuel; Fire Weather Index, or the fire intensity that combines the Initial Spread Index and the Buildup Index. MeteoStar Leads provides two levels of web interface and interaction for the user. The first of these is Leads Online. Leads Online provides the capability for users to view any Leads weather product, static or looped, through an internet connection. Any product capable of being produced by Leads can be viewed by the users through a web browser over the internet. The second level is Leads Interactive GIS Mapping, or Leads IGM. Leads IGM uses a framework that is built using open software standards for data sharing. Leads IGM is an interactive, browser-based viewer that enables the user to engage with data from a totally different perspective. Administrative tools provide for user management, organization management, role-based security, administrative messages, online help, custom branding, custom page creation, and custom menu creation. Leads Online is the web-based companion to Leads. Products created using Leads, either automatically when data arrives or manually by the user, can be displayed via the web. Many tools have been developed specifically for Leads Online to include bulletin generation, alphanumeric queries, briefing creation, customization, and role-based security. This is the front page of Leads Online. The page is totally configured by the user and shows the product selection as thumbnails on the opening page. A mouse click opens the product to full screen. Any product in the Leads product database is available to the user for addition to the main page. Features also include custom language selection and bulletin templates for WMO bulletin generation. Leads Online is managed and maintained through a series of drop-down menus. 3 of the drop-down menus are shown on this slide. User tools, which are used to set up and manage web page content. Administration, which is used to manage the database, users, user roles, and the products they have access to, as well as sending messages. The Integrated Help menu contains a link to the PDF user manual. Leads Online allows users to use the Leads web-based application to create and publish bulletins. These bulletins include general Met messages and aviation bulletins. Leads provides standard bulletin forms and checks for accuracy. Leads Bulletin Generator provides an interface to the GTS and ATN, AFTN message switches for publishing. Leads Online provides weather by route capabilities. The user enters in the flight plan details: origin, destination, alternate, departure date and time, flight duration, and flight altitude. Leads Online then returns all METARs and TAFs, AirMets and SIGMETs, significant weather charts, satellite imagery for the flight route, and a vertical cross-section for the flight route by hour of arrival at each waypoint. This slide shows Leads Online product examples. Vertical cross-sections, meteograms, soundings and skew T or tephograms. Our newest addition to the Leads product line, Leads IGM, is a cutting-edge, interactive, browser-based viewer that enables the customer to engage with data from a totally different perspective. A true weather situation awareness is available to Leads IGM users by simply using a standard browser. Leads IGM allows the meteorologist to perform most workstation tasks straight from the web. All data used with IGM is geo-referenced along with many web services and features that have been created or ported over from the Leads workstation. In addition, IGM provides a set of drawing tools containing all the WMO weather symbols and standard graphical tools. Like Leads Online, Leads IGM is a user-based web interface to the Leads product sets. Unlike Leads Online, Leads IGM is based on a global mapping system built by the user in layers. Each product layer can be turned on and off and allows panning and zooming over the global map database. Multiple layers can be viewed at the same time with tools to control the transparency of each layer. The product library for Leads IGM is populated by products created by Leads version 6.x. In addition to products created by Leads, user-gridded products and custom map layers can be used as well. The same administrator tools used by Leads Online are also used by Leads IGM, providing control by user and role. The product examples shown are surface station data, showing a current hydrograph and forecast rainfall for the next 3 days, QPF estimations from the GFS model over the catchments in the state of Paraná, Brazil. Clicking on the basin shows the forecast 48-hour accumulated rainfall. The Leads IGM product toolbar is shown on the left. Note the products are stored in user-defined folders. The figure at the top shows the surface winds over Panama. The lower figure shows a Google Earth map layer with satellite imagery and METARs. This slide contains examples of IGM displayed products. These examples include satellite imagery showing a hurricane and METARs, composite weather radar showing a hurricane and surface METARs, rainfall over Northwest Africa, and hurricane tracks with wind intensities from the U.S. National Hurricane Center. The Leads Alert architecture is based on a very flexible concept of components that are tied together using JMS. Simple alerts. The Leads decoder or a system script gather and store the data, then broadcast based on a simple user-defined alert condition, either the decoded data or a data receive message over JMS. Rules engines. The rules engines evaluate the incoming data based on rules which are a combination of criteria and filters, such as who, what, and where, to determine which alerts to fire. The rules engines also can provide a list of active alerts and can provide all clear messages when the threat is passed. The JMS inputs can also be used for other purposes other than alerting, like auto updates and other data processing. The third level in alerting is the level of getting the alerts to the users. This level includes routing, displays, acknowledgement, and logging. Leads alerting allows the user to configure the alert capability to fit his requirements. The user can define alert criteria, including conditional criteria, data types to alert on, the method of messaging, and the communication methods. Here is a short tutorial on how to create watchboxes and associated bulletins as an alerting tool. A weather situational threat is defined while looking at the thunderstorm and lightning activity in western Thailand. An alert box is drawn around the area, and a valid time and weather phenomena assigned from the lead's alerting template. A threat significance is assigned, for example, warning, watch, or advisory. The bulletin is then created and published. It is that easy with leads. This is the IGM web display. We actually created a marine and public warning with alert boxes for this area. The display is what the IGM user would see. Note that there are two different watch boxes. With a mouse click over the warning box, the associated bulletin pops up. MeteoStar and our Leads toolset can bring value to your enterprise. MeteoStar can design and deliver the best weather system for you. MeteoStar can train. MeteoStar can provide on-call support. Our software subscription service means your Leads software is always up to date with the latest Leads capabilities. MeteoStar can provide a backup data service if reliability and availability is a requirement. MeteoStar can provide staging and training systems to support all our installations. And MeteoStar is partnered with the National Center for Atmospheric Research, NCAR, who can assist with the implementation and tuning of a WRF weather model. The MeteoStar Leads toolset can provide a scalable end-to-end solution for your enterprise. A leads-based solution to provide decision support. A leads-based solution to provide decision support, protecting resources and saving lives. Our question is, what can we do next to help you? We at MeteoStar thank you for your attention and time.